Test cofunction identity. Show that area of a triangle is A equals to A square sine B sine C divided by 2 sine B plus C. Now this is a very good question, kind of difficult. So let's try to understand this problem. Now whenever we are saying area of a triangle and we are using the terms A, B and C, then it's better to first draw a triangle and see what we really mean to say, right? So let me draw this triangle for you here. This is my triangle. As a general triangle, don't think it's an equilateral triangle or something like that. It's a triangle with vertices A, B and C. Okay, let me say this is my A and that is my B and this is C. So whenever we name vertices like A, B and C, then the side opposite to vertex A becomes A and opposite to B is B and that is C. So that is what defines these small ABCs, and the capital ABCs are your angles, the internal angles of the triangle, correct? And now let's look into the area. So area is half base into height. So what is the height? Let's drop this perpendicular here, and if this perpendicular is dropped on CA, then this becomes perpendicular and the height is B to this point. Okay, let me call this H as height, correct? Now let's try to solve the problem and analyze what the situation is. So when we say area of a triangle, then area is, let's say area of a triangle is equals to half base times height. That is the area of the triangle. Now we know base in this case, and base is opposite to B, so I can always write base as B, so that is not an issue. But what is the height? Now height we can find in terms of angle C, right? So this is our angle C, and in terms of angle C we can find height. So we can use trigonometric identity using height and A. So this becomes related with the sine, do you see that? And then we can figure out what the height is. So that is one way of looking into height, right? So we can say that, well, height of this triangle is, so we'll use sine of C, right? So to find height, let me write here, height is equals to, so H, which is, let me first write what is sine C, then it becomes easier. So we'll go backwards, right? We'll say, well, sine C is equals to H over A. So height H is equals to A times sine C. Is it okay? A times sine C. So that is the height of this triangle, correct? Now, therefore, we can write, and we can also use our sine law. So I'm just giving you all the options so that it becomes easy for us to relate the things, correct? Now, the sine law is that A over sine A equals to B over sine B. So we can write sine law as A over sine A equals to B over sine B equals to C over sine C. So that is our sine law, right? So we are just trying to explore all the options, and then we'll put pieces together to find the answer, right? Now, so we can write now here area of triangle A is equals to half times base for us is B and height for us is H, and we found that H is A sine C. So H is A sine C. So that is our height. But as you see in the formula, we don't have B and we have some B plus C. There are different terms in it. So we want to find what B is in terms of A, because that is not in our formula. We got to prove that area is that much, right? Otherwise, half AB sine C is also the area of the triangle. Now we will use this sine law to find what B is in terms of A, right? So from here we can say A times sine B divided by sine A is actually equals to B, correct? So we'll substitute this value here and see what do we get. So we get, instead of B, A times sine B over sine A, and we already have A here, times sine C. So as you can see, we have already got A times A, which is A square. We got the sine B and sine C. Denominator is still different. So let me first rewrite this as how closer we are to our objective. So we have A square sine B sine C divided by sine A. Now we need to write A in terms of B plus C. So how can we do that part? Now for this, you also remember that what is the sum of three angles? A plus B plus C is 180 degrees, right? So we get A plus B plus C equals to 180 degrees. That will help us to figure out what is A in terms of B plus C, correct? Yes. So what is B plus C equals to? If you see this, B plus C is 180 minus A. That's right. So we can write this as half of A square sine B sine C divided by sine of 180 degrees minus, A is 180 degrees minus B plus C, right? Minus, so I'll write within brackets. Let me use brackets here. B plus C and bigger brackets, correct? So we know A is 180 minus B plus C. So we replace this. So that is what we got. So at least we have B plus C also in our formula now. Now what is sine of 180 minus B plus C? So that is where the function identities we are looking for here. So sine of, let us say one angle is theta. Let's say this is theta, right? So we'll say what? Let's say this is our acute angle theta, for example. Let's say this is angle theta, right? So now in this terminal arm, 180 minus B plus C is how much? That means this is 180, and 180 minus B plus C will make this. So that angle from here to here is actually 180 degrees minus theta. Do you understand? So if this is B plus C, then this is 180 minus B plus C. Now as you know, for sine is positive. You know the cost rule, right? So sine is positive here, correct? So this sine is positive here, and you know sine of 180 minus theta is actually equals to sine theta, right? So therefore we can write this as, A square sine B sine C divided by, I'm writing in this form, 2 is in the denominator, sine of B plus C. Do you see that? Because sine of 180 minus theta equals to sine of theta, and that is what we wanted to prove. Hence, proved. So that's a very, very interesting example. I hope you understand the strategies which we adopted to solve it, right? So look at it. When you're given a question in the form of a triangle with some sides, draw a triangle, label it, figure out what A, B, C should be. Sides opposite, they are named in lowercase, correct? That's the first thing. And then just drop triangle. It doesn't really matter. You could have started with C also. You could have got the same result, right? Because this sine law helps us to write one side in terms of the other angles. Do you see that? That's the important criteria here. So you use that, and then we use the property of a triangle that sum of all the angles is 180 degrees. And combining all those things, we got our result. So this is an excellent example. Go through it, try to understand the strategies, and I hope it helps you a lot in understanding this chapter. We are coming to a close to this co-function identities, and with this, I think it gives you a lot of confidence to work. Share with your friends and enjoy this part of trigonometry. Thank you.